has an out parameter after it, so it's not a trailing in with a default. I cannot use positional notation to pass the default for this one. I can't say, well, just pass in comma, comma. I can't pass in a null. That will pass in a null value. There's actually no way to skip over this one and use the default value for this one with positional notation. So let's take a look now at name notation. Here's an example of using name notation for all the parameters in their original order. So I simply specify the formal parameter name and the actual value with the equal greater than symbol. So over and over again, formal, actual, formal, actual. And the big advantage here, and the reason I talk about it in the readability section, is that now anybody coming along to this call to this program years from now can easily understand, instantly understand, which value goes with which parameter. With positional notation, unless I know this program pretty well, I'm not going to be able to understand what these values go with. In fact, I'm going to have to say, I better take a look at that code, and I bring up the code and I stare at the values and I say, okay, the first one is advertising budget, so that's the 5 million and so on. So it doesn't tell its own story. I need supporting documentation essentially. With name notation, no problem. The explicit association lets me know exactly what actual goes with what formal. But that's not all you get. When you use name notation, you can also skip over internal, non-trailing in parameters with default values, because I'm no longer relying on the order. So I can explicitly say, well, assign this one to this one to that, and I can skip anything that is an in parameter with a default value, and Oracle will pick up the default value. In addition, I can use name notation to change the order in which I specify my formals and my actuals. There's no ordering required because I'm doing the explicit naming. I'm not sure how much value there is to that. Perhaps under some circumstances, you might want to emphasize a different parameter up front. Finally, you can blend positional and notational. In other words, I can start with positional notation. I can switch to name notation. And I can basically get the best of both worlds, which usually means for me that most of the time I start with positional notation, or let's say I'm maintaining somebody's code who has positional notation used, and then we add some additional parameters. So let's say this used to have just 3, and then we added these 2 new parameters. Often what I will do at that point is take the time to use name notation. So I will add a name notation parameter. For my new parameters, because I'm figuring that I'm adding new functionality to existing application code. This is new stuff. I need to help people understand how it works. And then, of course, if I'm not feeling too lazy that day, what I really should do is go back and add name notation for all the others. But you can mix them together. And the thing to keep in mind is, once you switch from positional to named, you can't go back to positional because you've broken the ordering. So, name notation offers lots of different features and benefits. The most important one, I believe, is the readability standpoint. So I can explicitly tell you which arguments, which actuals go to which formals. Makes it much easier to read, understand, and maintain the code. So let's finish up by talking about one way in, one way out. Probably some of you watching this video used to be a COBOL programmer. They're still around. I didn't ever work with COBOL, but I did work with Fortran for a while. And generally speaking, modern developers tend to look down on COBOL programmers. They're so old school. They're dinosaurs. And hey, they created the first worldwide software crisis, Y2K, by not including the full 4-digit year number in their code. Well, hey, who can blame you when you're writing code in the 1980s or maybe even the 70s? You're not thinking that your code's still going to be running in the year 2000. And in fact, I think that if you look at how COBOL shops and COBOL developers wrote their code, you'll find that they paid more attention to process, whether it comes to how they write their code, how they manage their code, how they debug their code. I think that many of them had superior processes for writing higher quality code than we do in PLSQL shops today. And in fact, the structured programming methodology that was developed along with COBOL was widely adopted, and lots of what they talked about makes a lot of sense to PLSQL. So my feeling is, the next time you run into somebody who used to write COBOL, ask them to give you some tips about how to write better code. I think they have we have a lot to learn from them. And one of my favorites is one way in, one way out. And the idea is that in any block of code, there should be one way into that block of code, which in PLSQL is pretty much always the case. More importantly, there should be one way out. And the reason for this is that if you have, before I go into the specifics, if you have more than one way out of a block of code, a subprogram, a loop, whatever, when you're debugging your code, if something goes wrong, you have to figure out what exit point, what exit pathway was followed. It makes it a lot harder to understand what happened in your code, and it makes it harder to read your code. And the specifics for one way in, one way out that I'd like to talk about in this lesson is never conditionally exit from for loops and inside while loop bodies. A for loop is a promise. I will execute n number of times. A while loop has a boundary condition that specifies when you should stop, and that should be the only exit path. And what I mean here in general is besides an exception. Obviously, if an exception is raised, that's going to force a termination of that part of your block. You will exit from your block. So I'm talking about non-exception, normal processing. Never exit from a for loop and a while loop from inside their bodies. Also, avoid gotos, and there's not a whole lot to say about that. I think it's pretty well